Hi students, welcome back to my channel. In this video we are going to discuss another linked list, another type of linked list, that is a circular linked list, CLL. In previous video we discussed one linked list, that is a single linked list, and another one is double linked list, and the operations performed on this linked list. So these two types we have discussed. So if you understand these two types, then it is easy to understand. If you have not seen my previous lectures on SLL and DLL, please go and visit this single linked list and its operations, double linked list and its operations. Then it is easy to understand this video, circular linked list. Now, coming to the definition of circular linked list. CLL, shortly we can call it as a CLL. See, circular linked list. That means there is a linked list. So linked list is nothing but a collection of nodes. So a linked list is there. Now I am representing one simple linked list which consisting of suppose 4 nodes. Okay. This is SLL. What I am representing is SLL. Suppose 8, 6, 4, 3 are the elements, and the last node's next pointer is a null pointer. Okay. So now generally what we have represented, for example, here it is 100, here it is 200, here it is 300, here it is 400. Okay. So now 8 nodes next node is 200, 6 nodes next node is 4, which is 300, 4's next is 400. So that data is 300. This is SLL. Now in single linked list we can move in forward direction only. Once you reach to the last node, it is taking more time to reach back or to come back to the first node. That is one of the limitations in single linked list. So I am repeating. So in single linked list we can move in forward direction. You can't move in backward direction. So now in DLL, if you observe double linked list, in double linked list a node consisting of 3 partitions like this. So in this last node's next pointer is null. So in this also, so here you can move forward direction and you can move backward direction. That you can see in my previous videos as I mentioned. So in this double linked list you can move in backward direction. So now in circular linked list the point here it is, if you are in the last position and I want to come back to first position. Already you are in last position, then you want to come back to the first position. Then circular linked list is used. So that's why here it is a circle. See, if you are representing circle, in circle there is no starting and ending. In the same manner here also 8, 6, 4, 3 and last nodes next is not null now. Then what is present here? In this first node address will present. That means here 100 will present. That is circular linked list. Now see, clearly I will represent one example for circular linked list. Now suppose as usual 4 nodes are there in circular linked list. Suppose 4, 10, 6, 3. Okay. And now represent addresses. Suppose here it is 100, 200, 300, 400. Here as you know 200, here it is 300, here it is 400. So 3 nodes, last node is in single linked list it is null pointer, but here it is not null pointer. It is storing address of a first node. So like this we will represent. This is circular linked list representation and storing the addresses. Now, what are the operations performed on circular linked list? What are the operations performed on circular linked list? As usual operations similar to single linked list, double linked list. One is insertion operation. Second one is deletion operation. And third one is search operation. Similar to single linked list, double linked list. So we can perform these three operations. Now coming to insertion operation. Insertion operation in single linked list. What is the meaning of insertion operation? Insertion operation means we have to add one new node. Inserting a new node in single linked list. Sorry, now here it is a circular linked list. Inserting a new node in circular linked list. Now, how can you insert a new node in circular linked list? Example. For example, this is my existing circular linked list. There is a single link present between the nodes. Now, the definition is similar to single linked list only. Collection of nodes in which a node consists of two partitions. One is data partition and another one is a pointer to next node. But the last node's next pointer is storing address of a first node. That point we have to mention in the definition of circular linked list. Okay. So now circular linked list 10, 8, 16. Now the addresses 100, 200, 300. Here it is 200. Here it is 300. See, first node address is 100. Okay. So now I want to perform insertion operation. So insert of 10 comma 3. That means element 10 I want to insert in the position 3. I want to insert. How can I insert now? See, how can we insert? So now this is first position, second position, third position. Now in third position here we have to insert. That means here we have to insert. Similar to single linked list only. Like this we will represent. Element is 10 and what here it consisting of 300. For example, this node address is 400 and this is 400. Then what is the difference between single linked list and circular linked list? In single linked list, last node is identified with a null node or null pointer, not null node. It is null pointer. In circular linked list, last node is identified as it consisting of address of a first node. It consists of address of first node. Like that we can identify the last node. Okay, like this we will represent. So in generally in single linked list or double linked list we will move pointer. Generally we will represent like this. Pointer is not equal to null. Like that we will represent. But here we will not represent like this. Suppose this is PTR and also PTR1. PTR1 is moved. Then PTR1 not equal to PTR. PTR1 not equal to PTR. Like this we will represent. That is only the difference between circular linked list and single linked list. Now we have represented now. So as usual, here as usual we will represent. Now after insertion. After insertion, CLL is 10, 8, See, after 8, what is the node here? This node 10, 16. This is the last node, na? So last node's next pointer is null pointer. Last node's next pointer is null pointer. I will represent it again. Now 8, and here it is 10, and here it is 16. Last node's next pointer. Like this we will represent. Now, as usual, addresses. This is 100. 8 node address is 200. Here it is 200. 10 node address we assumed it as 400. 16 node address we represented as 300. So here 200, here 400, here 300, 300. This is the last node, and here it is storing 100. Like that, insertion operation is performed in circular linked list. You can say this as a circular linked list or circular single linked list. Why? Because single link present between the nodes. Single link present between the nodes. Okay. So now coming to next operation, that is deletion operation. Deletion operation on circular linked list. So it is also similar to circular linked list and double linked list. If you have not seen those operations, please see my previous videos, the operations on SLL and DLL. Now, how to perform deletion operation, and what is deletion operation actually? Deletion operation is nothing but deleting a node. Deleting a node from the list. Deleting a node from the list. List here it is nothing but from circular linked list. Okay. So now example. For example, this is circular linked list. Eight, 6, 4. This is circular linked list. 100, 200, 300. Now, I want to delete this node. I want to delete this node. Or otherwise, you may get doubt, madam, this is similar to SLL and DLL. Why don't we delete this one? Okay, we will do that one. Delete. Now, we want to delete this node. We want to delete this node. Okay. So now how to delete this node? Okay, you can delete this one. After deletion, which node will become last node? This node will become last node. After deletion, this node will become last node. Okay. So this is the last node. So what is the important point in circular linked list? Last node's next pointer must store first node address. Last node's next pointer should store first node address. So what shall we do now? So now we will give the link. That means here we will store 100. That means here this is 8. 8 after here 6, 100, 200. Here it is 200. Here it is 100. So this is resultant circular linked list after deletion operation. Similarly, search operation. How to perform search operation? Search operation is nothing but a finding a particular element. Finding a particular element. Particular element, or finding whether an element is present in the list or not. That we can say it as a search operation. Okay. So now for example, how can we do search? So example, how can we do search? Suppose 8, 6, 3, 4, and this is the given circular linked list. Now I want to search for the particular element 3. See, whenever you are performing search operation, there are two cases. One is element may present in circular linked list, element may not present. Okay, that means element found is nothing but element is present. Not found means element not present. Now, what shall we do? How to find out whether the element is present or not? So, we will compare like linear search. Compare 3 and 8. What is a searching technique? As you know, so we are having two types of searching techniques, linear search and another one is a binary search. Again, if you have not seen these videos, please go through these videos of linear search and binary search. Now, here in this search, we are applying linear search. Linear search is nothing but sequential search. That means we will start from first node and then we will move to second node, third node, fourth node and so on. Now, 3. We want to search for 3. Then what should we do? We will compare 3 and 8. So, both are not equal. Then next 6 and 3. Both are not equal. 3 and 3. Yes, both are equal. So, the case is element is found. That is nothing but successful search. That is nothing but a successful search. These are the operations performed on circular linked list. Students, if you have any doubt, you please send your question in the comment box. If you like this video, please like, share and subscribe my channel. Thank you very much. Have a good day. Bye.